All right, let's talk about chapter 1.3, which is quadratic equations. And our objective here is to use appropriate methods for solving quadratic equations. I'm going to go over 4 different ways to solve quadratics. And then on the test or on most problems, it'll be you choose whichever one is best or whichever one works better for you. So a quadratic equation in X is an equation that can be written in standard form: ax squared plus bx plus c equals 0. And a cannot be 0. Okay, what that means here, or what that tells me, is that this term cannot be, or this coefficient cannot be 0. If it is 0, this goes away, and then I'm just left with these two, which is just a linear equation. Okay? However, I can get rid of these and still have a quadratic equation. Okay, my key thing here is that I have to have x squared. If I have some variable, which most time we use x, if I have some variable squared, then I have a quadratic. Okay. Going back up here, for example, if I have 2x squared equals 7, that is a quadratic. Okay. Even though I don't have these two terms, it doesn't matter. Okay, so methods for solving. So factoring, which is one that you've probably dealt with a lot in Algebra 1 and Algebra 2. Square root, which is also common. Completing the square you had in Algebra 2. However, you probably use this the least. So we'll be looking at this, and then the quadratic formula. Let's review the quadratic formula. Okay, there it is. If you can't remember it, I got a little tune here that will help you kind of get it stuck in your head so that it's easy to use. And it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so replay this video, get it down. We'll be using it in class quite a bit. So we're going to solve these next couple by factoring. Okay, so going through the process of factoring, we look for the greatest common factor and rainbow method if we need to, those kind of things. Okay, so this is just a simple one here. I've got a 1 here, so that's good. No greatest common factor, so we just need factors of 16 that subtract to 6. That's 8 and 2. X and X signs are different. The bigger one is negative. So then we will take 2 of these factors here and set those equal to 0. So you get x equals negative 2, x equals 8. And there are your answers. So real simple problem there. Okay, now if you notice on this one here, it does not equal 0. So before we can factor it, we must get this to the other side. So we will add 4 to both sides. So x squared minus 6x plus 9 equals 0. So factors of 9 that add to 6. 3 and 3, x signs are the same there, both negative. So you have x minus 3 equals 0, and x minus 3 equals 0. X is 3, x is 3. Now we don't write that twice, so what we'll do is we'll write x equals 3 m2. Now the m stands for multiplicity. Now what the multiplicity just tells me is that this answer appears 2 times. So if I had this answer 3 times, I'd write m3. Okay. This is really helpful for when we go to creating equations and looking at the graphs and that kind of stuff. So another factoring here. Okay, again, we have to set it equal to 0. So we will say 2x squared minus 3x equals 0. Now I have 2 terms here, so we'll look for greatest common factor, which is x. So 2x minus 3 equals 0. And x equals 0, 2x minus 3 equals 0. So x is 0, comma, we will add 3, divide by 2. So add 3, divide by 2. So x is 0 and 3 halves. Now, you may have looked at this a little bit differently, as I did originally, and say, well, can't I just divide both sides by x? We'll get 2x equals 3, divide by 2, and x equals 3 halves. Well, you may notice that we've got one of the answers, but we're missing the second answer. Okay? Well, think about up here what we did. We divided by x, meaning that x could not be 0. If it was, we can't do this. And then if you look over here, it is 0. So I cannot do this method because I divided by 0, and I cannot do that. Okay? So make sure we're setting it equal to 0 and factoring what is there. Square root method. So from now, we're going to do the square root method. You should notice that we are missing the linear term, the x term, okay? Which is good. That means I can use the square root method. So we are going to isolate this x squared. So we will do plus 27. 3x squared equals 27. Divide by 3. Divide by 3. X squared equals 9. Square root, x equals plus minus 3. Now, a couple things here. Why do I need the plus minus? Well, we have an equation and we took the square root. And 3 times 3 is 9, but also negative 3 times negative 3 is 9. And if nobody ever told you this, okay, when you were solving equations, you were doing the order of operations backwards. Okay, so here's your variable, and we want to add and subtract first. Well, what did we do? We added first. Then you're going to look for multiply and divide. We divided. Then you look to take care of your exponent, which we did. Then you would look for parentheses. After that, you would go back to the bottom and see if you could do it again. Okay, so we'll use this and work with this a lot. I'm moving on. Okay, so still square root method. So we will subtract 27. 3x squared equals minus 27. Divide by 3. X squared is minus 9. Square root both sides. Now that the only time I can do it is if this entire side is squared. That's when I can square root. I can't square root up here because the whole thing is not squared. So I have x equals plus minus, and the square root of negative 9 is 3i. I get the I from the negative, and the square root of 3 is 3. So if you're having troubles with those, breaking those radicals down, let's watch the radical video. Okay, so notice here that this whole side is squared. That tells me I can simply take the square root of both sides. So then I'll have x minus 2 equals plus minus 4. 4 times 4 is 16, and negative 4 times negative 4 is 16. So plus 2. So x equals 2 plus minus 4. I can figure out what this is. So x is 2 plus 4, which is 6. 2 minus 4, which is negative 2. And there are my answers. Okay. Now this one here, most of you probably would have said, well, can't I do this? X minus 2 equals 16. Can't I FOIL this out and then move this over and factor it or quadratic formula? Yes, you can. You can, but this method is much, much faster than FOILing this out and moving it over and doing it that way. Completing the square. The process of completing the square is making this equation so that I can factor it. Okay, that's what I'm doing. So we will first isolate my x's. So x squared plus 8x, okay, making sure that this is a 1. If that's not a 1, which we'll see here in just a second, I have to take care of that. So plus blank is 3 plus blank. Now, how do I know what goes in this blank? What goes in there? That is going to be b divided by 2 squared. So 8 is b, so we'll say 8 divided by 2 squared, which 8 divided by 2 is 4. 4 squared is 16. So we'll put 16 there and there. So then this side is now a perfect square, meaning that my two factors are the exact same. And they are both in this form. Okay, so you'll have x some number squared equals, and in this case, 19. Now, how do I know what number goes here? Okay. It will always be this number right here going there. So b divided by 2 goes here. So 8 divided by 2 is 4. Positive 4. Now, this is now in the square root form. So I can just square root both sides. X plus 4 equals plus minus the square root of 19 minus 4 minus 4. X equals negative 4 plus minus the square root of 19. And we are finished. I still have two answers here. Now, what happens if that leading term is not a 1? Like in this case. We're simply going to divide everything by that number. We'll put a star by this one. This one's a good one to know, good one to study, good difficulty level. So we have x squared minus 4x plus 13 over 3 equals 0. Okay. So we'll say move this over and add the blank. So x squared minus 4x plus blank equals negative 13 thirds plus blank. How do I know what goes in the blank? That is b, so negative 4 divided by 2 squared. So negative 4 divided by 2 is negative 2 squared is 4. So then we will factor this left side as a perfect square. So x plus minus something squared. What goes in here? Well, it's this right here. So the minus 4 divided by 2. So minus 2 equals, now we got to add these two together. So this is 4 over 1. I need a denominator of 3. So this becomes 12 thirds. So negative 13 thirds plus 12 thirds minus 1 third. Now it's in the square root form. So we'll take the square root. Take the square root. If x minus 2 equals. All right, now let's look at this for just a second. We've got plus minus, always. The negative tells me it's an imaginary number. And then we've got the square root of 1 over the square root of 3. I cannot have the square root of 3 on the bottom, so we'll multiply top and bottom by square root of 3. So we get square root of 3 over 3. This is radical 3 times radical 3 is radical 9, and the square root of 9 is 3. We got radical 3 over 3. Then we simply add 2. And we need to write it in a plus bi form. So we got 2 plus minus radical 3 over 3 I. And that would be my answer. Okay. So make sure we're writing it in proper form. We're getting the right number in here. And again, we're in a plus minus bi. Formula. So the quadratic formula here. That's how we want to solve it. It does not matter what numbers are here. Okay? It just matters that we equal 0. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a Hey, again, there's that song that's going to get stuck in your head to help you know it. So this is a 1, and that is A. B is -4, and C is -1. So we're just taking these numbers and plugging them into here. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So -4 is 4, plus minus the square root of -4 squared is 16, plus 4 over 2. So 4 plus minus the square root of 20 over 2. Now I should notice that I can break down the square root of 20. That's 2 and 10, 2 and 5. So there's the group. So that comes out front, and the 5 stays underneath. So you have 4 plus minus 2 radical 5 over 2. And notice here, all 3 of these terms are divisible by 2. I cannot just cancel these because of this plus minus. So I have to cancel all 3 at the same time. So that's 2 plus minus radical 5. Okay. So a couple additional things about the canceling here. If I have 4 plus minus 5 radical 2 over 2, I cannot cancel. Okay, I cannot cancel these 2. I have to do all 3 of them. But this cannot cancel because it is under the radical and none of these are. Okay, so I have to leave it alone. So I cannot cancel here. Yeah. All right, so we're going to set it equal to 0, so we'll move this over. Make sure we're putting it in the right order. Okay, this goes in between the 2. It's ax squared plus bx plus c. So we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I have 4 plus minus the square root of 16 minus 32 over 2. So 4 plus minus the square root of -16 over 2. Keep reducing. Okay, 4 plus minus 4i. Okay, the square root of 16 is 4. The negative tells me I over 2. And again, I can cancel all 3 terms at once. So I get 2 plus minus 2i. And there's my answer. Okay, last one here for quadratic formula. I've got it equal to 0. It doesn't matter that this isn't a 1. That's okay. So this is A, B, and C. So again, we're just plugging it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a, and reduce. Now, if these are fractions, don't let that bother you. We can either put the fractions in here, or we can get rid of it. How do we get rid of fractions? We simply multiply by the common denominator, the entire thing. So we have 4 plus minus the square root 16 minus 16 over 8. So that's 4 plus minus the square root of 0 over 8. The square root of 0 is 0, and plus minus 0 doesn't change anything. So we have 4 over 8, which is 1/2 multiplicity of 2. I have to have 2 answers. The fundamental theorem of algebra tells me whatever my variable is, or whatever the exponent is on my variable, the highest one, that's how many answers I should have. This tells me I have 2 answers and they are the same. Okay. Kind of going along with that, we have what's called the discriminant. The discriminant tells us the types of solutions we will have in a quadratic. So we've got b squared minus 4ac. That is my determinant. Or sorry, the discriminant. Where does that come from? The quadratic formula. It comes straight from there. Okay? If I work this part out and it gives me a positive number, I will have two real solutions. That's like back here when we got 20 there, we had two real solutions. If it is 0, which we had up here, I got 0, I will have one real with multiplicity of 2. Okay. And if it is negative, if this under the radical is negative, I will have two complex. That was like this one right here. I got a negative 16, so I have to have an I, two complex. This makes great true, false, or multiple choice questions for the test. So a couple word problems. Word problems will become the norm now. We will have them very frequently. So from 1999 to 2001, the price of Abercrombie & Fitch's stock was approximately given by the function P equals, and you can read it there, where P is the price of the stock in dollars, T is the month, and T1 corresponds to January 99. When was the value of the stock worth $30? Okay, well, I want to know, when is it $30? When is the price $30? So we're going to take 30 and plug it into P. I got 30 equals 0.2 T squared minus 5.6 T plus 50.2. Quadratic, we just set it equal to 0 and solve it. Plus 20.2. Now I don't want to deal with the decimals, so I'll just move everything to the right one, which is the same as multiplying the whole thing by 10. So I have 2t squared minus 56t plus 202 equals 0. I notice that I can divide everything by 2. So I have t squared minus, what is it, 28t plus 101 equals 0. So factors of 101 that add to 28. Sometimes this is just a little bit of a guess and check here. Let's just use the quadratic formula here. So we have t equals, because I don't think this factors out. Okay, 101 I think is a prime number here. So t equals negative b plus or minus the square root of b squared. So negative 28 times negative 28, so 784 minus 4ac all over 2a. So then we get 28 plus minus the square root of that 784 minus 101. 380 over 2, and we'll plug this into the calculator here. So we got 28 plus the square root of 380 divided by 2, 23.75, so t equals 23.75. And we have 28 minus the square root of 380 divided by 2, 4.25. Now the reason I changed that to decimals is I want to know what month. Well, it says January 99 is t equals 1. So I'm at t equals 4. So t equals 4 will be April 99, because January is 1, February is 2, March is 3, and so forth. And then go on to 23. So this is actually a quarter of the way through April. 23, if I go up, December of 99 is 12. December of 2000 is 24. The 24th month, so we're at the 23. So this is November of 2000. November of 2000, and it's 3/4 of the way through. So we're almost to December of 2000. That is when my stock reached this $30. Okay? Between these two, it was either higher or lower. Okay? Hitachi makes a 60-inch HD TV that has a 60-inch diagonal. If the width of the screen is 52 inches, what is the approximate height of the screen? So this is a basic geometry problem here. Okay, a lot of times pictures make things easier, but it is a quadratic equation. We will use the Pythagorean theorem, and we'll say x squared plus 52 squared equals 60 squared. Okay, so minus 52 squared minus 52 squared. So x squared equals 896. And the square root of that. So x equals plus minus about 30. Okay. Now, what is my answer? Well, what is the approximate height of the screen? I can't have a negative, so we'll say about 30 inches is the height of that. About 30 inches. So here's your suggested problems. Focus on these word problems here. They'll could be on the test there. And if you have questions, please don't hesitate to let me know before or after school. This is at THS Mr. Jones signing off.